Hi, my name is Wes Hill. I'm one of the founders and the CEO of Menta. We're a startup with strong ties to Duke University that generally lives in the space of operating room analytics, applying novel Internet of Things type data streams for hospital resource management. When COVID-19 hit the US, we all started working from home. As engineers, clinicians, we saw the same DIY ventilator being invented and reinvented over and over, a motor compressing an ambu-bag. It looks simple, but it's not. It requires sensors, complex electronics, and I thought this can be simpler. Over 3 days, we put together a ventilator that uses fluid flow and the siphon principle to provide ventilation with pressure, volume, and timing control without any complex electronics. The foundation of our device is a single chamber with a fluid inlet, a siphon, and an air exit. In this case, water is our fluid. By turning the water on, we fill the chamber, pushing air into the patient's lungs until either the chamber is full, meeting the maximum volume, as controlled by the size of the chamber, or until maximum pressure is reached. This is controlled by the height of the siphon. Once either of them has been reached, plateau pressure is maintained until the water supply is turned off, at which point water level in the chamber lowers, pulling air back in, allowing for exhalation. This is a modular ventilator. It requires simple exhalation and PEEP valves and filters at the mask. Supplementary oxygen can be added as an input to the chamber. How water is supplied is dependent on the requirements of the user. Now, given a water source, we can set up a siphon-based supply that allows this ventilator to function without any electricity at all. What you see here is an auto-cooler pump, circulating water to an upper tank which provides the pressure. We can change this manual valve to a solenoid with an analog timing circuit precisely controlling inhalation and exhalation timing. Height and volume of our siphon and chamber control the ventilation parameters, and with skilled mechanical designers and clinicians on our team, we're confident we can develop intuitive mechanical controls for these aspects. What we have developed here is different, it's unique, but most importantly, it's simple. From a safety and a regulatory viewpoint, the system has very few components to malfunction because it operates on basic physical principles. It offers all of the controls required to perform safe and efficacious ventilation. These parts are so common and inexpensive that sterility is achieved by making any patient interfacing component disposable. We built this over a weekend with several trips to Home Depot in order to demonstrate the principle. With additional resources, imagine the possibilities of what we can do. Water is life. Let's use it to help our loved ones breathe.